Thanks for the invitation and thank you for the attendance. My name is Carlos del Castillo. I work for the ECCS, that is the European Convention for Constructional Steelworks, and I play the role of advocacy, project, and sustainability manager. The ECCS was set up in 1955 and is a federation of national associations. That means that our members are the National Association of the Steel Construction. We are a platform in which we are bringing together the steel producers, the steel wheel contractors, European research institutions, and also the academic world. And our mission it is to develop an effective technical and promotional network for the sustainable use of steel in construction. It is also to improve the competitiveness and innovation in construction through research projects, and also to represent the profession, that means the steel construction, into different forums. That they could be ECREDI, CENT, ISO, the development of the Eurocodes, DigiGrow, well, at different levels. Of course, we are also implementing an important range of dissemination activities, so we are in charge of the coordination of the activities to produce the Eurocodes related to steel and steel composites. We are also in charge of some design manuals on these topics, and of course of training courses. We are also coordinating and participating in European research projects, and we are in charge of different events that it could be the Eurosteel, International Bridge Symposium, European Steel Design Awards, and others. And our main tools for communications are our website, newsletters, and apart from the training, we have also this Journal of Steel Construction that is quarterly published, in which you can find the last innovations in steel and its calculations. And now let's focus on the core contents on this webinar, and we will start with the role of reuse in sustainable construction. And here I would like to bring just an overview in the general presentation of well, how can we implement reuse, what is the role of reuse, but here particularly I want to introduce how reuse fits sustainable construction. As you all know, construction has different phases between Europe. So on the one hand, we are a key economic sector. We are responsible for almost 10% of the GDP. We are giving employment to 20 million people, and there are also over 3 million companies, 90% of them SMEs. However, construction it is also responsible for many impacts. 40% of the energy consumption, 36% of the CO2 emissions, half of the raw materials consumption, and a third of waste generated and water use. So we have this need and this mandate to go into a model that the current state of art needs to shift to circular and carbon neutral construction. And that means very simplified that no waste generation, energy efficiency, the reduction of resources needed, and of course, we need to do this being, of course, cost-effective, safe, and durable. At the end, we need safe and durable buildings, and we need affordable buildings. So we need to implement all these activities and all these changes without committing our core values also. Now, how does circular economy fit in sustainable construction? Well, it's one of the two main pillars. The first pillar is going to be carbon neutrality. But then we have circular economy. And circular economy is really central to no waste generation, to energy efficiency, not so on the primary energy demand of buildings, that means the buildings that, the energy that buildings consume, but in the embodied energy. And also for the reduction of resources during the construction activities. So one important focus that we have to have, and is one of the objectives for this webinar, is giving a first step to set connections, is that circular economy must be implemented along the supply chain. It is not possible to implement circular economy just from one position in the supply chain or individually. So we will need to collaborate from design, construction, operation, renovation, demolition, and manufacturing of products. So that means that circularity really means circularity. Well, what are the environmental benefits of the implementation of the circular economy in terms of the different aspects that I have previously introduced? Firstly, no waste generation. Europe has tried to reduce the waste generated by construction and demolition industry through the Construction Demolition Waste Directive. Despite it aimed for a 70% of recycling of waste, it really failed, and only about 50% was achieved with very few exemptions. And the truth is that in most cases it is downcycling or backfilling. The new versions of this legislation and implementation of the circular economy roadmap will set much more stringent requirements. We will have to be aware. And we will have for the first time regulations in which we will be asked to use recycled, reuse, or sustainable source materials. So that means that circular economy is going to be a requirement to be fulfilled also in new construction. Then we will have to focus on energy efficient buildings, where the EPBD, that's the Environmental Performance Buildings Directive, and the national regulations will set, particularly the national regulations, very stringent objectives in a real sum term. So, unlike the previous legislation that I'm talking about, the EPBD has been very successful. So that means that the energy, primary energy demand of building has really decreased, and we are all aware that a very efficient building is not only more comfortable, it's not only better, but it's also cost efficient, and it means savings. So the energy that is being consumed during the use phase is going to decrease, and is significantly decreasing. So the main net contributor to carbon footprint and global warming potential is going to be the embodied carbon. That means the energy that is used for materials. And here is when the circular economy, through high quality recycling, and particularly will reuse, has the potential to reduce the carbon footprint. Basically, a reuse of materials is a net near zero carbon material. And it's not only that we are saving raw materials, but water, energy, and energy consumption, but the fact is that something that is reused, the only energy associated has to do with dismantling, transport, and maybe refurbishment or reparation. And not only we will be able to integrate reused materials with a very low carbon footprint, but also it will be possible through the implementation of this concept of whole life cycle analysis that the benefits of circular economy and so of reuse can be capitalized through module D life cycle analysis. We are moving from this current cradle-to-grave approach to a cradle-to-cradle approach in which the end of life of the materials and the benefits, environmental benefits associated to it, can be claimed during this first stage. Good. And finally, we will have that the reduction of resources consumption. That's something that the taxonomy and the CPR and other will implement. And basically, as you may see in the legislations that are starting to define these levels, and for example, the EN 15978, that it is the standard that is regulating the life cycle analysis at building level. Here we can see that it's not only that we have to reuse, but we have to implement high quality recycling. So that means that reuse or pure stream recycling, that means those that can really bring a benefit, will be the values that, the actions that will provide the highest value, while material recovery or energy recovery will be on the downsides of the table. So in order to qualify for circular economy, reuse or pure stream recycling will be necessary. Okay. So finally, is reuse the optimal end-of-life option for construction materials? Yes, for sure. Why? Because reuse, including design for reuse, means cost savings, increased revenues, particularly for the demolishers, minimal footprint. I don't think that any green technology will get the benefits of reuse. We can do it in a very flexible way, from complete buildings to structures, manufactured products, or constituent products. We will generate almost no waste, and we have the chance to mitigate environmental burdens not only by using recycled or reused materials, but also by advancing the benefits of the circular economy. And also really important, it will generate local economic and social benefits. That means that it will be quite complicated to get everywhere this kind of new green materials that will be associated to some specific manufacturing sites where renewable energy is available, when you have access to some specific feedstocks of raw materials. However, reused material, if properly implemented, will be available everywhere. And now I would like to move to part 3, in which I will address more specifically steel in reuse and construction. So basically, I would like to start saying that reuse is feasible to be, steel is feasible for, reuse is feasible for steel, I'm sorry. In fact, from the GRC reports, we can see that the problem with steel reuse, it is not the lack of technology. The problem is that there is not established practices. And unless that steel has been exposed to radioactivity, fire, severe corrosion, severe fatigue loss, or practice deformation, the fact is that we can really reuse it. And in the case that we cannot reuse the steel, then we have the possibility to recycle reuse as an end-of-life option. And once we go into reuse, then we have to pay attention to the economic benefits and the reusability, because we can reuse the elements like the whole building, the structure, the components, constituent products or scrap. But the fact is that while the most benefits will be from reusing the direct structures of components, the more reusability will be in the case of scrap. So we need to find a balance about what are we going to reuse, what are we going to recycle it, and in which form are we going to recycle. Well, on the next step is how can steel be reused? Well, that's fortunately easy. It is possible because of the clause 5.1 of the EN 1090 Part 2, that it states that the use of constituent products not covered by harmonized standard is possible. And in this case, what we have to do is provide the specification of the material properties. How to do it? Fortunately, there are already standards and recommendations. What is now available is we have the Swedish guidance for structural steel reuse, the progress project outcomes that it was developed from the ECCS in collaboration with Rookie, with BTT, with SCI, with the Aachen University, and other institutions. And there you have a complete guideline about practices and certification methods. And also there is a quite well developed guideline made by the SCI, that is the UK Steel Construction Association. And all these guidelines are going to crystallize into a technical specification that is currently being developed by the TC135. Of course, these guidelines, they have a scope and they have limitations, but there is material enough to proceed with the reuse of materials, particularly in execution classes 1 and 2, as we will see later. Then steel will also play an important role on reuse in construction, not only for the reuse of steel, enabling the reuse of other materials. While steel is already a circular economy, and then we are aware that it is possible for us to reuse or recycle the steel and that most steel is recycled, then the reusability of buildings can not only rely on the recovery of steel or reclaiming of steel. That means that we need also to enable the reuse, for example, of precast concrete panels, CLT floor systems, and this is possible by combining steel structures with bolted connections with all these kind of systems. And in this case, while concrete can be mostly recycled as an aggregate, when you are recovering the full panel, then it keeps its structural properties. And it's the same for CLT. Maybe you can recover it by means of energy, or maybe you can really do other kind of recovery. But if you can reuse again the element like a floor, then of course the benefits they are higher in terms of economic and environmental benefits. And of course we can implement specific solutions and technologies to enable the circularity of envelopes. Envelopes, you will see in the next years in the circular economy roadmaps, that is one of the elements, the facades, the envelopes, the cladding, that generate the main fraction of construction and demolition waste, and they are going to be asked to be designed for reuse and reuse when possible. So here we have many solutions in which we are simplifying based on steel and supported on steel, the secondary structure, so that at the end we can use long span elements that can be easily adapted for new uses and also can be renovated or reused. So here steel will also play a key role, enabling that other materials that traditionally have problems to be reused, it is possible to do it when combining design for reuse. And this, of course, will mean that we are moving from this pure construction to hybrid, composite, and multi-material approaches to construction. Okay, what are the environmental and economic benefits associated to steel reuse? And this can be applied to many other materials. For example, reuse steel is near zero carbon material. So that means that the primary steel involves 2.5 tons of carbon dioxide per ton of steel. If manufactured on electric arc furnace, that means that based on scrap, it could be up to half a ton of CO2 per ton of steel. And if we are talking about the most advanced solutions, that these are, for example, the electric arc furnace 100% scrap, fully powered by renewable energy, then you can halve this half a ton. But in any case, the secondary processes for rolling, forming, and so will involve an important footprint. However, reuse, the global warming potential is only devoted to the installation, transport, and retrofitting, and it's minimal. It's 2% on the primary steel. So we are not needing energy, we are not having emissions, we cannot only use constituent products, and the fact is that there will not be so near zero steel and other materials available. And if available, they will be available locally, they will be expensive and very likely over-demanded. And maybe construction is not the best place for them. So here we have that the benefit is not only economic, but it's also environmental. And at the beginning, when we were considering only economic reasons, now there is a powerful environmental reason for the reuse of steel. And even when designing, as I said before, we have the chance to capitalize the benefits of reuse or recycling. And this is what is called Module D. And like I have said before, Module D refers at the end of the benefits and loads beyond the system boundary. What that this means is that the material that's recycled really involves a saving on the next life of the material, and you can claim it in advance in the Module D. In the case of steel, the mitigation is really high. It's 70% for the case of recycling, and it could be even over 90% for the case of reuse. And this regulation that I have referred before, the EN 15978, that refers to life cycle analysis in buildings, is already splitting scrapping, scrap for reuse and scrap for recycling. So that means that this will be accounted differently. Other benefits, when you are recovering what you are using recycled material, the Module D becomes positive. And if the end of life is reuse, then the Module D for recycling is also negative. And also very interesting, when you are reusing steel, then 1 ton of steel becomes 1 ton of steel. But when you are recycling, 100.1 tons becomes 1 ton. So there is a loss of properties, a loss of materials. So it's even more efficient. Okay. So now let's see if there are examples already of reuse now that we have the possibility, because the EM 1090 is open for this. We have the guidance, and we have also well, some benefits. It is possible to reuse, yes, and there are many benefits. I'm going to very briefly introduce 4 examples from the Progress project that I have referred before. And here we have, for example, an industrial building that is produced from another larger frame building, which a structure was taken and put in place in another area. This is the NTS building in Thirsk in the UK, and here you have the link to really get a more detailed explanation. And the progress guidelines and the webinars available in the ECCS website make sure that they are full of very valuable information that will make you sure that reuse is really a reality nowadays. In this case, we have the Hydrotin office in Timisoara, in Romania, and an hydraulic testing laboratory was transformed into a 5-story building. The complete, not the constituent products that they were in the other case, that part of the constituent product was used to make a new building. In this case, the complete structure was modified to produce these new office buildings. And again, you can find here the information. The next example is quite curious because we are not talking about a second life, but even a third life. It based on T2 hangars that they were produced in UK during the Second World Wide War. And in this case, first, it was a new hangar in the Sesteenhoven Airport in, I think it's Rotterdam. And finally, later, it became a bus station in Schiphol. Schiphol is also quite popular because their airport has been designed for reuse, and it's a nice example of circular economy. Okay, then another example that's quite curious is an owner of a market that wanted to produce something different, and what did with the demolition is taking the complete building and reuse it and make a new design on a different area. In this case, it's the same owner, it is the same country, and it's quite easy to do it because they are the same legislations, but I have included because it's a curious example because composite columns and trusses, they were reused, and also the sheathing. So the quality is close to reusing the building, and the environmental benefits, they are quite high. And again, you can find a more detailed case study in the documentation available from this Progress project. Good. Now that we have an overview of how steel can be recovered, how can contribute to the recovery of other elements, in our last example, we see that it's not only that the steel structure was reused, but we have also the chance to recover the seating, the envelopes, and composite structures. Then we have to evaluate what are the opportunities for the demolition industry. Nowadays, what is the current scenario? Well, steel is currently a consolidated circular economy, but it's based on recycling. 90% of steel is recovered. The data that I have is 6% is reused and 93% is recycled. I think that maybe the 6% is a little bit optimistic, but it's okay. And 30% of the current productions comes from scrap. That means that the scrap is melted for new steel, and this represents 30% of the overall volume of steel manufacturing. However, reuse is a niche practice limited to some profiles and maybe some stockholders. So most of the steel is sent to scrap in arc furnaces. But we can see that in the future, this is not going to be the case. What are the forecasts? Well, first of all, is that the green steel transition is going to imply relevant cost increases. I think that the new technologies that will be near zero, they will be based on direct reduction of iron. They will bring other technologies that we are not even aware, but basically they will be more expensive. And some forecast that we can have from this consultancy that you see here is that basically the cost is going to be about almost the double of the standard price. And also, due to the implementation of circular economy, 50 to 70% of the materials will be based on scrap. So that means that it's going to be electric furnace. What happens? That we have a really important potential for reuse to become a common practice. We will see that we will get higher benefit than selling scrap. And also we will have a scenario in which design for reuse, efficient dismountability techniques, and building digital passports. That means that all the information that we need for recycling and reuse, it will be available on our BIM models, on the same as our EPDs, that they will be online or available in repositories. So it will not be so complicated to get the certificates, will make reuse quite feasible. I think that, but this is something that is a pure estimation. It will be possible that 10 to 20% of the final steel production comes from reuse. So that means that just by implementing new practices, that they are cost efficient and that they are generating benefits and an economy, we can really mitigate 20% of the footprint of steel and also do it in a very efficient, sustainable way. So I think that that we have a really interesting scenario, but not only for the steel manufacturers. We have it for the designers, that they can sell and develop technology that is going to be constructed for more sustainable environment, and of course for the demolishers, that at the end they're going to play a key role within this scenario. Good. And now, how can we identify these materials in buildings? Well, from the ECCS and our network, we have conducted an interesting work on that, and also some introductions have been made, I think, also in this forum by BTT. But we need to integrate these procedures in guidelines and the pre-demolition audits. But basically, the feasibility of recovery will depend on the availability of certificates. That means all the documents regarding the building, the date of production, steel and other materials. In the case of steel before 1970s, it's a more complex material. We cannot be so sure as using something that we call modern steel. The building history, so we assure that no fire, no earthquakes, no exposures to strange conditions. And of course, the execution classes that they have to do with the building design of the design for reuse. But if we are talking about quasi-static execution classes 1, execution classes 2 buildings, it's not so crazy to think that buildings can be reused or the constituent products can be reused. Particularly in the future when the BIM models and the digital passports will really collect all the necessary information to make sure that we are having this information available. So I think that's important to gradually and according to available technology and information, integrate the reuse of steel and also other components if designed for reuse in pre-demolition audits. So then is when we need to think about how is steel recovered. And that means about the contributions from the demolishers. The work that we are conducting up to now is based on what we think that the demolishers do, but we are not sure of what we are really doing. So I think that makes sense that we start working on what is the available technology. In fact, reuse is going to have, the way that steel is reused will have a huge impact on the reusability and the feasibility of reuse. So despite there is a trend on developed system for its reuse, then we will have to take into account that this will be only available for future buildings. But we need to also recycle what is available on existing buildings. and not limit to steel. If reusability of components, the only component that we can extract that provides a benefit, it is steel, then we will have an economic complication. Why? Because at the end, it's only one component and I have to implement much complex processes. So the materials that we can recover, the more the materials that we can recover, the better will be the economic feasibility of the system. And there are bolted structures that have been prepared for reuse, but they are not so extended. And at the end, we need to understand that excavators and gas or cut shears are going to be the most implemented techniques. So we will have to think about what is possible and work on what is possible, creating a forum, a collaboration with EDA. But basically, I think that up to date, working with the conventional techniques that I have mentioned, and reusing constituent products. That means the beams, the pillars, and so, and sending the connections and the nodes for recycling. That means that scrap for melt could be a quite efficient way and quite on the safe side way to get materials from existing buildings. So we don't really need to do something new. I think that the current state of art is enough to get reused material from buildings. Okay. And then we will have to think about how to introduce into the market. Now, reclaimed steel is not easily available. There are some stockists who can make this available. And depending on the owner of the building, not only the constituent products will be available, but apart from very few sites in which they can sell profiles from demolition sites, it's not so easy. So it is only for very few products and related to the stocks available. The main reason is an economic driver, and in the case that is not an economic driver, is mainly related to lighthouse project, in which is some kind of exotic practice, in which I can tell that I have recovered some component, I have done something that is very sustainable or that can be even close to marketing. But it's not something systematic, and it's not something that we are implementing in order to recover as much material as possible. So we will have to work on how to build these tools to introduce steel, reuse steel, and other components in the market. And we will have to do it with clear responsibilities, because the fact is that now the responsibility is about who's responsible and what are the consequences of recovery, what are the consequences of certifications are not specifically allocated. And also we have different possible testing protocols. So there is a need here to improve the way that reuse steel is going to be introduced in the market. But nowadays it is possible, and it's mainly related to stockists or demolishers. Okay. So once that we have provided an overview of what is currently possible and the way that reuse is implemented, then we can go for the challenges for the demolition industries. The challenges, they are, of course, also opportunities. The first thing that for me is critical is collaborating along the supply chain. As I have said before, it is impossible to go into the circular economy just from an individual perspective. At the end, we need to involve all the supply chains because knowledge is distributed. So that means that the demolishers that have a real clear understanding of what can be recovered and how to recover and how to reclaim materials, but they don't have maybe the knowledge about the different phenomena that are happening during the life of the building or the dismantling and what can create a situation in which reuse is precluded or prevented. So it is necessary to create a common place in which all the stakeholders in the supply chains, they can set a dialogue. So if we are not aware of the other stakeholder practices and the limitations of the different stages, and the design is not done in order to reuse, we are not building to allow reuse, and we are not considering that some operation situations will generate problems, then we will be assuming risk and making recurrent mistakes. So that means that on the one hand, the supply chain will be broken, so there will not be circular economy. And on the other hand, we will have parallel processes, not consistent, in which it will be very complicated to harmonize and extend. So we need to cooperate along the supply chain at EU level and agree the scopes, and not only for steel. If we really want to implement circular economy, steel cannot be the only material to be reused. We need to recover as much materials and reclaim as much materials as possible. So we have to do it on the design phase from the beginning. And considering that the market is quite segmented, we need to do it in a way that the different providers of services, they are not acting independently. At the end, we need to have some common practices, and I said before, a common space to talk about how to implement reuse. Then we will have to develop the optimal tools, and we will have two different scenarios. On the one hand, when we are working with an existing building, and when we are thinking about the future reuse in new buildings. In the case of existing buildings, there will be limitations because they have not been designed for being reused, and it will not be easy to get the necessary information on the certifications, on the designs, on the drawings and everything that could be necessary, or even the history of the buildings. So we will have different limitations in tools for recovery, in the existing information, and we will have to very likely assume a very conservative approach. While when we are talking about new buildings, the declaration of performance will be available. They will be digitally available. So we will have BIM models, passports designed for reuse, optimized installation processes that at the end will be designed specifically for reuse. And here is when we can set reuse like a common practice. I think that very likely for execution classes 1 and 2, partially in execution classes 3, but for sure in execution classes 1 and 2. So that means that reuse can become a common practice that can have even a similar share to a scrap. That means remelting for producing new materials. And it's important that we will have to develop tools and methodologies according to real needs. I think that there are two main risks on reuse. On the one hand is reusing what is not safe, and what at the end can create very risk situations and even fatalities. And of course, trying to recycle something that is ultra complex and is far from being cost efficient. So we will have to be very, very cautious and focus our actions just to get benefit, to create economic impact, and to do something in which we feel safe. And at the end, we are not having any kind of hesitate about, okay, is this legal? It is not. It is risky. I am doing something crazy. We need to work in this direction. So now going on the development of tools for existing buildings, we have to do it progressively according to real needs. So we need to understand what is feasible and what could be common practice. And I think that constituent products for industrial warehouses, particularly single and few stories in low seismic activity areas, I think that is a set of the market that is very compatible with reuse. And there it is possible to get important amounts of materials and not only steel. There are also some interesting opportunities, and for example, multi-story buildings with composite slabs that they represent huge shares of the markets in some countries. So we will have to work in the assessment protocols of fatigue, and also we will have to work on the methodologies to recover and to split the slab from the structure, the primary, the secondary structure, and to finally evaluate the different components, including welds. The assessment of welds is something that is not currently developed, and we will have to do it. And all these processes, we will have to do them while we are implementing activities to support the adoption of reusing new buildings. So what we discover working in existing buildings, we have to translate it into new buildings to prevent this happening in the future and also to maximize the reuse practices. So we need to avoid investing efforts in what should not be reused because it is very risky and because it's not cost effective or is simply some kind of exotic practice for marketing. Well, if you can afford it, it's okay. But if we want reuse that is really supporting construction and sustainability, then we need something that it is very efficient and it is very safe. Okay, for new buildings, then we have to develop the methodologies to maximize the share of reuse, not only steel, other elements also in buildings. So we need to develop cost-efficient design for reuse and adaptability approaches, not to doing very, very complex academic solutions that at the end very hard to build, but also to dismantle. We will have to develop the tools that really make everything available. We need to work on monitoring the activities like seismic activity, fatigue or loads that could create problems, and introduce concepts like, for example, now seismic activity may be a critical issue because what is execution class 2 in a low seismic area, it is execution class 3 in a medium or high seismic activity area. So some technologies that at the end they have been designed to prevent plastic damages on structures in the case of seismic activity maybe could make sense to be developed. And also the methodologies to evaluate the fatigue, loads, and to extend to all kind of components. And finally, we will have to develop the methodologies for making a decision about retrofitting, refurbishment, recovering as a structure, building, or whatever. So it's important that everything is coordinated so we avoid inconsistencies and ensure interoperability. Okay. Once we have the tools, then we will have to work into creating a legal framework that even if something happens and we don't want this to happen, that legality is with us and we can demonstrate that what we have been done is sensible, is safe, and it's only an exemption. And the problem is that everything that's related to reuse will be distributed between different actions. So I have highlighted here the CPR, in which reuse materials, the promotion of reuse is one of the main objectives of the CPR, and there will be different articles that need to be taken into account. I will explain very briefly later because I think that its regulation is only the subject for a webinar. Then we have the SEN committees, and particularly the TC135 is with this, within this committee. There is a technical specification on reuse being developed, but there is also another on assessment and retrofitting of existing buildings and refurbishment of buildings. And they are in different committees. It's curious. So coordinating these activities is going to involve efforts because what is no sense is that what we are doing in a committee use different evaluation protocols or tools than other. And finally, we have the APBD, the taxonomy, levels, the ISO, Construction and Demolition Waste Directive, the Circular Economy Roadmap, where the requirements in terms of values and also the quantification methodologies are going to be defined. So we need to make everything coherent, and that at the end, what is being stated in one regulation is not making null what we are doing in others. And of course, again, this thing also happened at national level. And we know that, for example, the SEN TC350 is developed, 135 is developing a technical specification on reuse, but also Denmark and Norway and Netherlands. So I think that these national committees, they should be connected and somehow selecting first an harmonized approach and also what is the best approach and share the same approach. So we will have to work in consolidating this common framework for really enabling reuse. And now, like the last slide before the conclusions, I would like to very briefly introduce just some topics. Curiously, but the CPR is allocating the responsibilities to the economic operators in charge of the installing the elements. I think that this should be the demolishers. But you need to take into account that Article 2 defines what's under the CPR, and the Article 12, it says what kind of reused materials can be put again in place with a declaration of performance for used materials. And here it is stated that it will be the member states who will be in charge of the responsibility of creating the protocols, but will be the economic operators, the installing or dealing with used products, who are in charge of when these materials can be used, in which conditions, and also the certification. So it will be very important to participate because the steel construction, we are developing this technical standard, but at the end, we'll have to be integrated into the CPR, and we will have to try to do that the national committees, they are adopting this standard or are aware of this standard. And we will have to do it at the end with the demolishers, who are the ones who are in charge of the certification of used material, those who are the installing. And also, of course, we will have to integrate the architects, the design offices, and others. And here it's very important, those entities that at the end they are in charge of design, construction, operation, and the installation, because they could be maybe the first adopter of these reuse practices. And just something for you to inform you is that the Technical Committee 135 from the SEN committee is working on a technical specification that will complement the clause 5.1 on the EN 1090 part 2. And with these materials, then it will be quite possible to get a legal document or a document coming from a SEN that supports the recertification and introduction of reused materials. Nowadays, it's only a standard that is in a technical specification that is being drafted. It's quite close to completion. We hope that it will be in about a year, it will be available and it will be possible to use it. But it's only the first approach. We will have to extend the scope. We will have to work on different situations, but it is possible to do it. So now we have the first technical specification being produced. And I'm sure that for other materials and maybe at national level, then we can get also some other specifications. So, well, just to conclude before the questions and answers, I would like to very briefly introduce a slide with conclusions. First is that the reuse is one of the main opportunities for sustainable construction because of reduced waste, embodied energy, and resources consumption, but also because of the economic and social benefits. We will generate a new economy based on reuse, and it will be quite a big share of the market. It could be 20-25% of the overall steel production. That's really important. Then it is possible to currently reuse steel, particularly in execution classes 1 and 2 buildings. It is also possible to implement solutions that enable the reuse of other elements that maybe they are not so easily reusable, like it could be concrete slabs or CLT or facades. And there are existing methodologies and examples for safely use of reuse. And I think that also for the reuse of cladding, for the reuse of other components. So it's necessary to be aware of the existence of this information. Steel must become a common practice, and we need to build the new supply chains, the new economic activities, first on the existing state of art, and then developing the optimal tools so that by 2015, which this Green Deal is setting their objectives, then the reuse is really a common practice and is representing a relevant share of the market. And also really important, we need to consolidate reuse, and that means coordinate activities and collaborate across the supply chain, from the designers, design offices, to the constructors, owners, demolishers, and so. And we need to do these activities to capitalize what is currently possible, to develop the new tools to maximize the impact of reuse, and finally, to consolidate a robust regulatory, legal, and standardization framework that will at the end make us safe and feel comfortable with this practice. Reuse is a practice that can generate some rejection from some of the stakeholders, and if our legal framework is robust, is consolidated, and is agreed on safe practices, this should not be a problem. So, at this point, I will conclude my presentation and will let you for the questions and answers, and even to some comments about potential collaborations. Then you have my email and my contacts here. And better by email, because I think that, we are now on remote working, so by phone it will be more complicated. But we are really looking forward to building new alliances and creating new networks in the framework of reuse and circular economy. So now it's the floor is yours.